Good day, learners. Welcome again to our lesson in General Physics 1, Differentiating Vector and Scalar Quantities. So, after finishing the module, the learner should be able to define vector and scalar quantities and give example of the vector and scalar quantities. So let's begin. So let's think. What is the difference between this illustration? How about the quantities on the left? How do you differentiate the quantities on the right? So basically, we can compare that both sections have same values, right? But the difference is that in the left part of the diagram, we can see direction. So how is this related to our lesson today? So let's continue. So our lesson today is all about the scalar and vector quantities. So when we say scalar quantities are quantities described by a magnitude, which means it has a unit alone. When we say magnitude is a numerical value in the measurement. So as we go back in these figures or illustration, we can see that both of these illustration have the same magnitude, right? But the difference is that on the right part of this illustration, we can see that there is a direction. So let's continue. The distance is a scalar quantity. It is the total length of the actual path traveled. Based on the illustration, if you walk from A to B, then to C, your total distance traveled in is 55 meter. So, as you can see in the figure, we have three stations, right? So we have letter A, letter B, and letter C. So as you walk from letter A to letter B, your distance, the measurement of your distance traveled is 20 meter. So this is 20 meter. Now, you went to your school with another 35 meter. So basically, the total distance traveled is 55%. So, what about this 40 meter? How is this related to this illustration? So let's continue. Aside from the distance, here are the other scalar quantities. Okay? Mind you that speed, area, pressure, temperature, time, power, volume, amount of substances or moles, and mass are examples of the scalar quantities. Now, let's proceed with the vector. So when we say vector quantities are quantities described by both magnitude and direction. A while ago, we discussed about the scalar quantity. It has only magnitude and a unit, right? But in vector quantities, we can see that vectors have direction. So a vector quantity can be denoted using a single letter with an overhead arrow. So take note, class, that if you could see a letter A with an arrow on its top, that denotes a vector quantity. So, at this portion of this slide, we can see different examples of vector quantities. So, 500 meter is a magnitude, right? Now, 500 is a value, magnitude. This is the quantity, meter. Now, let's include the direction. So the direction is left. So that is a vector quantity. Aside from that, we have also 7 miles per hour north. Then we have also 60 degrees northeast. These are the examples of the vector quantities. So, the direction indicates the path where the quantity is heading. The cardinal directions north, east, west, and south, or left, right, up, down, positive, and negative are some of the common used terms to describe the direction of the quantity. So can you see the difference between the vector and the scalar quantities? Let's continue. A vector quantity can be represented graphically using an arrow. So this is now a vector quantity. So we have 5 vectors that have the same magnitude and direction because they are all directed towards that area. Now, the arrowhead points to the direction of the quantity while its length represents the magnitude. So take note class that if this arrow doesn't have any head, it only denotes that it has only a magnitude. But if it has a head arrow like that, so you can say that this is a vector quantity. So a vector quantity is presented already in this illustration. So consider A as the initial position and C as the final position. Even if you travel from A to B then C, your displacement from A is 40 meters south. Unlike distance, the direction is considered in displacement. So take note of the word displacement. Okay? When we say displacement, displacement is the difference between the final and initial position of the object, thus, direction is needed. So, that is the importance of having the direction. It would really present the displacement. So without displacement, you are not able to see whether this is a vector quantity or a scalar. Maybe you can say that this is a scalar. Okay? So let's begin. Let's continue. So take note class that velocity, force, acceleration, momentum, and weight are examples of vector quantity. So you may encounter these quantities in our next discussions. So remember, when we say scalar quantities are quantities described by a magnitude with a unit alone. When we say vector quantities are quantities described by both magnitude and direction. So that ends the presentation. If you have any question, then just message me on the comment box, or you can just message me directly. Okay? So God bless everyone and happy learning.